In the autumn of 1940, Germany, Italy, and Japan signed the Tripartite Pact in Berlin and formally declared themselves the Axis powers. On paper, it was a historic alliance. Three of the most militarily aggressive nations on Earth had committed to a common cause and in theory to mutual support. In practice, however, the three powers had almost no meaningful coordination. They fought their wars on opposite sides of the planet with no shared strategy, no joint command, and for most of the conflicts, no reliable way to even communicate. Germany needed rubber, tin, molybdenum, and tungsten from Asia to sustain its war machine. Japan needed advanced radar technology, modern torpedo systems, and aircraft engine designs that its own engineers had not yet mastered. The two nations possessed exactly what the other required and were separated by roughly 14,000 miles of ocean, patrolled by the most powerful Allied naval forces in history. The solution they devised was one of the most extraordinary logistical undertakings of the entire Second World War. They would send submarines, alone, across half the planet, through waters crawling with enemy warships and patrol aircraft, carrying the most sensitive military technology either nation possessed. The Japanese called these voyages Yanagi, the word for willow, bending but not breaking. What they actually became was a story of extraordinary audacity, bad luck, Allied intelligence superiority, and a fundamental strategic miscalculation that ensured the program would ultimately fail to deliver what either side needed. This is the full story of the Yanagi missions. To understand why Germany and Japan needed each other in the first place, we need to understand the specific gaps in each nation's military capability by 1942. Germany's problem was primarily material. The Allied naval blockade had severed Germany's access to the raw materials of the Pacific and Southeast Asian regions that Japan now controlled. Rubber came from Malaya, tin came from the Dutch East Indies, tungsten and molybdenum, essential for hardening steel for aircraft engines and armor-piercing ammunition, came from mines in Asia. Without a reliable supply of these materials, German war production faced hard ceilings it could not push past. The surface blockade runners that had been making the journey in the early months of the war were being hunted down with increasing efficiency by British and American naval forces. By 1942, the loss rates on surface cargo voyages were making the runs economically pointless. Germany was spending more in ships and crews than it was receiving in raw materials. Japan's problem was technological. The Imperial Japanese Navy had accomplished remarkable things with the equipment it had developed domestically, but by 1942 it was beginning to recognize that in certain critical areas, particularly radar, submarine detection technology, fire control systems, and advanced torpedo design, Germany had produced solutions that Japan's engineers had not yet reached. Germany's electric torpedoes left no wake, making them nearly invisible to their targets. German radar detection equipment, the kind fitted to U-boats to warn them of incoming Allied aircraft, was more sophisticated than anything Japan had deployed. And Germany's emerging jet aircraft programs, the designs that would eventually produce the Me-262, represented a category of technology that Japan desperately wanted access to for its own aviation development. Initially, both nations had used surface merchant ships to make the exchange, and these surface Yanagi missions had managed to move some cargo in the early months of 1942. But as Allied anti-submarine and surface warfare capabilities expanded through 1942 and into 1943, the surface routes became untenable. Submarines were the only option that offered any realistic chance of making the journey without being intercepted, and so both Germany and Japan began the process of converting their largest submarines into underwater cargo vessels and planning the most ambitious undersea voyages in naval history. The first submarine of the Yanagi mission departed in the spring of 1942, and the vessel chosen for it was not a U-boat but a Japanese submarine, the I-30. Built at the Naval Yard and commissioned in February 1942, The I-30 was a Type B-1 submarine of the Imperial Japanese Navy, a category of vessel considerably larger than the typical German U-boat of the period. At 356 feet in length and displacing over 2,580 tons submerged, the I-30 had a range of 14,000 nautical miles and carried a crew of 110 men. One of her most distinctive features was a watertight aircraft hangar mounted forward of the conning tower, designed to house a Yokosuka E-14Y reconnaissance floatplane, a compact single-engine aircraft that could be assembled on deck, catapulted into the air for reconnaissance missions, and recovered from the water when it returned. It was an extraordinary system, giving a submarine a reach that extended far beyond its own periscope depth. The I-30's outbound cargo was specific and carefully chosen. Germany had formally requested strategic raw materials, and I-30 carried 1,500 kilograms of mica, essential for electrical capacitors used in communications equipment and radar systems, and 659 kilograms of shellac, a natural resin required in the production of military munitions and electrical insulation. She also carried the blueprints for the Japanese Type 91 aerial torpedo, the same weapon design used in the attack on Pearl Harbor, which Germany wanted to study for its own development programs. The I-30 left Penang in April 1942 as part of a larger submarine group assigned to conduct anti-convoy operations off the East African coast. After spending time reconnoitering Allied ports from Aden to Dar es Salaam, launching her float plane on reconnaissance missions over several harbour installations, and participating in an attack on Allied shipping near Madagascar, the I-30 detached from her group and began the special mission that would make her history. She rounded the Cape of Good Hope, transited the South Atlantic, and on the 2nd of August 1942 arrived in the Bay of Biscay off the northwest coast of Spain. What met her there reflected the significance both Germany and Japan attached to the occasion. 8 Junkers Ju-88 bombers from the Luftwaffe flew air cover overhead. German M-class minesweepers swept the waters ahead. The submarine was escorted into Lorient, the largest of the 5 German U-boat bases on the occupied French Atlantic coast, with the precision and ceremony of a naval review. On the dockside, Grand Admiral Erich Raeder, the Commander-in-Chief of the Kriegsmarine, stood waiting to receive her. Beside him was Admiral Karl Donitz, the commander of the U-boat arm. The Japanese naval attaché to Germany, Captain Yokoi Tadao, had travelled from Berlin with his staff for the arrival. The bass band played as Commander Shinobu Endo and his crew came ashore, and Endo was presented with a German medal, almost certainly the Iron Cross Second Class. A woman presented him with a bouquet of flowers, the traditional U-boat base welcome that had greeted returning German commanders throughout the war. It was, by any measure, a historic moment. The I-30 was the first Japanese naval vessel ever to reach occupied Europe. While the I-30 was dry-docked inside one of Lorient's massive bomb-proof U-boat pens for repainting and engine overhaul, Commander Endo and his crew travelled to Berlin. There, Endo was received by Adolf Hitler personally at the Reich Chancellery and decorated a second time. The crew made a sightseeing trip to Paris, climbing the Eiffel Tower and shopping on the Champs-Élysées. These were men who had sailed halfway around the world through enemy waters, and by every account they were treated as honoured guests and important allies for the duration of their stay. The Germans used the time productively. The I-30 was repainted in the standard grey of the Kriegsmarine, more appropriate for operations in the North Atlantic waters she would have to transit on her return voyage. Her Japanese anti-aircraft armament was replaced with a quad-barreled 20mm Flak-Vierling 38, the standard German anti-aircraft weapon that her crew would need to operate in waters where Allied aircraft were a constant threat. A Metox radar detector was fitted to warn the submarine of incoming Allied aircraft radar emissions during the transit of the Bay of Biscay, which had become one of the most dangerous stretches of ocean in the world for submarines. The I-30's float plane was serviced and actually flew test flights over Lorient, the only time a Japanese naval aircraft operated from French soil during the entire war, a fact that contributed to later Allied rumours never confirmed that Japan had established an air unit in occupied France. The return cargo was considerably more extensive than what the I-30 had brought from Japan. The Germans loaded a U-boat torpedo fire control system, essentially an early analog computer for calculating attack solutions. They provided G7 air-launched torpedoes and G7E electric torpedoes, the weightless design that Japan most wanted. A Metox radar detector with full documentation, sonar detection equipment, a new search radar, a hydrophone array for underwater acoustic detection, 50 naval Enigma cipher machines, anti-tank guns, a Zeiss anti-aircraft fire control system, 20mm anti-aircraft guns, blueprints for air defense ground radar systems, and an assortment of technical documentation and specialized equipment. The manifest also included approximately 1 million yen in uncut diamonds, transferred as payment for the technology. The total cargo represented a comprehensive snapshot of German naval and technical capability in the summer of 1942, and its arrival in Japan would have meaningfully advanced Japanese development in several critical areas. The I-30 sailed from Lorient on August 22, 1942. She made the return voyage successfully, arriving at Penang on October 9th, and was then ordered on a short deviation from her planned route to deliver 10 of the Enigma machines to Japanese naval headquarters in Singapore. It was a detour of only a few hundred miles, but no one had provided her commander with charts showing the locations of the Japanese defensive minefields in Singapore harbour. When the I-30 exited the harbour on October 13, 1942, she struck a British mine that had remained in the swept channel. 13 men died in the sinking. Most of the cargo, so carefully loaded in Lorient and carried safely across 14,000 miles of Allied patrolled ocean, went to the bottom of Singapore harbour. Some equipment was later salvaged by Japanese Navy divers, including portions of the German anti-aircraft armament, but the bulk of what the I-30 had carried from Germany was lost to a friendly fire mining in Japan's own occupied port. Despite the loss, the mission had demonstrated something important. A submarine could complete the round trip between Japan and occupied France. The voyage was possible, and both Germany and Japan remained convinced enough of the programme's potential that they continued it. What neither side yet understood was that the Allies had already obtained the intelligence tool that would make the later Yanagi missions far more dangerous than the first. In March 1943, the Japanese ambassador to Germany, Hiroshi Oshima, sent a cable to Tokyo reporting a suggestion from Field Marshal Erich von Manstein that large older U-boats should be converted specifically as cargo submarines to make the Germany-Japan run, now that surface blockade runners were being sunk at an unsustainable rate. Ambassador Oshima recommended that Japan adopt the suggestion as quickly as possible. The cable was sent in Japan's purple diplomatic cipher. It was intercepted and decoded by Allied signals intelligence within days. From that point forward, the Allies knew that the Yanagi submarine missions were continuing, and they began devoting specific resources to intercepting them. The submarine I-8 completed the second successful round trip in 1943, delivering Japanese technical materials to Lorient and returning with a cargo that included German torpedo systems and technical personnel. The I-34, attempting her own Yanagi voyage in October 1943, was intercepted and sunk by the British submarine HMS Taurus off the Strait of Malacca before she reached Europe. The I-29 completed a partial mission that year, first rendezvousing with the German submarine U-180 in the Mozambique Channel in April 1943, an open ocean transfer that exchanged passengers between two submarines of two different navies in what remains a unique event in naval history. Among the passengers transferred to I-29 from U-180 was the Indian nationalist leader Subhas Chandra Bose, who was travelling to Japan to lead the Indian National Army in the Axis cause against Britain, becoming the only civilian ever exchanged between submarines of two different navies at sea during the war. The I-29 eventually completed her voyage to Lorient in early 1944, returning with one of the most significant cargoes yet assembled for Japan. Her holds contained an HWK-509A-1 rocket motor from the Messerschmitt Me-163 Comet, the world's first operational rocket-powered fighter interceptor, and a complete Jumo 004B jet engine from the Me-262, Germany's revolutionary turbojet aircraft. She also carried blueprints, technical documentation, and 14 Japanese passengers, including engineers and military personnel. Everything Japan needed to begin building its own jet aircraft program had just crossed the Atlantic in a single submarine. The I-29 never delivered it. On July 26, 1944, running on the surface in the Philippine Sea on her return voyage, the I-29 was intercepted by the American submarine USS Sawfish. The intelligence that placed Sawfish in exactly the right position at exactly the right time came directly from Ultra, the Allied signals intelligence program that had been reading Japanese naval codes for years. Sawfish fired 4 torpedoes, 3 connected. The I-29 exploded and sank within minutes, taking most of her crew and the actual Me-262 jet engine to the bottom of the Philippine Sea. The blueprints and technical documents had been dispatched separately by air and survived, and Japanese engineers did use them as the basis for 2 aircraft programs, the Nakajima Kika and the Mitsubishi J-8M Shusui, both direct derivatives of the Me-262 and Me-163 respectively. But neither aircraft reached operational service before Japan's surrender in August 1945. The jet engine itself, the hardware that would have allowed Japanese engineers to reverse engineer Germany's most advanced propulsion technology, was gone. The 5th and final Japanese Yanagi voyage fell to the I-52, which departed Kure in March 1944 carrying a cargo of 146 bars of gold, 9.8 tons of molybdenum, 11 tons of tungsten, and assorted other strategic materials totaling several tons in weight, plus a complement of Japanese naval engineers and technical personnel. The cargo she would receive in France, already packed and waiting on the Lorient dockside, included acoustic torpedoes, jet fighter engines, radar systems, vacuum tubes, ball bearings, bomb sights, optical glass, alloy steel, and 1,000 pounds of uranium oxide. The complete transfer, if it had been accomplished, would have represented the most significant single exchange of advanced military technology in the entire history of the Axis partnership. Allied signals intelligence knew the I-52 was coming. Aircraft operating from the American escort carrier USS Bogue had been briefed on the submarine's route and approximate schedule. On the night of June 23, 1944, in the mid-Atlantic, a Grumman TBF Avenger torpedo bomber from Bogue, equipped with airborne radar, located the I-52 on the surface and attacked with homing torpedoes and a Mark 24 FIDO acoustic homing torpedo, a weapon specifically designed to home in on a submarine's propeller noise after entering the water. The I-52 sank with all 146 crew members. The gold, the strategic metals, and all the Japanese engineers aboard went to the bottom of the Atlantic in roughly 17,000 feet of water, where the wreck was eventually located by researchers in 1998. In August 1944, the Kriegsmarine formally declared the I-52 presumed lost. Japan made no further attempts to send submarines to Europe after that point. Germany also made one final attempt to complete a Yanagi transfer in the opposite direction. The submarine U-234 was a converted Type 10 beam mine layer, reconfigured as a long-range cargo submarine. In April 1945, with Germany clearly weeks from collapse, U-234 departed Kristiansand in Norway for Japan, carrying one of the most remarkable cargoes assembled during the entire war. Her holds contained a crated Messerschmitt Me-262 jet fighter, an HS-293 radio-controlled glide bomb, the latest German electric torpedoes, technical drawings covering a range of advanced weapon systems, and most significantly, 1,210 pounds of uranium oxide, the material that could theoretically support nuclear weapons research. Among her passengers were 2 Japanese naval officers, a German general, German naval officers, and civilian engineers and scientists. On May 10, 1945, the war in Europe was over for 2 days. U-234 received Admiral Donitz's surrender order and surfaced to comply. The technology she was carrying, the technology that both Axis powers had been trying for 3 years to transfer through the Yanagi Missions, surrendered along with her to the United States Navy. The Yanagi Missions produced one of the clearest examples in military history of what happens when a program is strategically sound in concept and tactically impossible in execution. The logic behind the missions was correct. Germany had technology Japan needed. Japan had materials Germany needed. Submarines were the only vessels that could conceivably survive the journey. What defeated the program was not any flaw in that reasoning, but the cumulative weight of 3 factors that proved insurmountable. First, the distances involved were simply at the extreme limit of what submarines of the era could manage, leaving almost no margin for error, evasion, or mechanical difficulty. Second, Allied signals intelligence, through the decryption of both the Japanese Purple diplomatic code and the naval ciphers, gave Allied forces foreknowledge of almost every mission after the first, allowing them to position intercepting submarines and aircraft with near-surgical precision. Third, the timeline of the war itself worked against the program. By the time the Yanagi missions reached their most ambitious phase in 1943 and 1944, both Germany and Japan were fighting defensive wars. The technology being transferred was urgently needed immediately, not in 6 to 12 months after submarines had completed round trips of 28,000 miles. The I-29 sank with Germany's jet engine technology 4 months after the Normandy landings. The I-52 sank with Japan's gold a week after D-Day. The war had simply moved faster than the submarines could. The full cargo of U-234, the Me-262, the uranium oxide, the torpedo systems, and the scientists who knew how to use them, arrived in American hands in May 1945, months after the technology could have influenced anything.